Assalamu alaikum friends, this is Imran Ali and you are watching my YouTube civil engineering channel. Today I will teach you about BOQ of highway construction project and all activities involved in construction of a highway. So guys, before we start our today's lecture, please subscribe my YouTube channel and must press bell icon so that you will get updated with my new videos. This is chapter number 2, estimation, and lesson number 2, bill of quantities. Full form of BOQ is bill of quantities. Is a construction bidding or costing document that contains an itemized list of required works, activities, tasks, materials, parts and labor with their cost. BOQ consists of 5 main columns. First column after serial number is item description. In this column, complete detail of any activity is mentioned. For example, supply and installation of any product or material according to drawing and specifications from the approved source. Next column is unit of measurement. Unit of measurement of any item or work or activity will be mentioned in this column. It might be in cubic meters, square meters, running meters, numbers or tons. Next column is rate of item. Rates of all items, materials or activities quoted by the contractor will be mentioned in this column. After making rate analysis of all items. Guys, you can watch my video about how to make a rate analysis of civil works. Link is mentioned in top right corner of the screen. Or you can watch later from the playlist on the end screen. Next column is quantity of items. After taking off quantity of all materials or items according to drawings will be mentioned in this column. Next column is total amount. Total amount of any item, material or activity or work will be mentioned in this column. Guys, when a contractor submits tender or bidding documents to win a contract offered by a government department or private department, the contractor have to prepare and submit BOQ along with tender documents. A quantity surveyor or cost engineer is responsible to do this job. An estimated BOQ is provided by the client, is normally called engineer's estimate, which is further submitted by the contractor along with quoted rates of all items or activities of the construction project. Above or below the engineer estimate according to the feasibility and market rates. Today we will talk about a BOQ of highway project which contains all activities involved in construction of a highway. These activities are further categorized in 7 main bills of BOQ according to the sequence of their execution in construction of highway. Guys, as you can see on the screen, this is a soft copy of BOQ of a highway project in Excel format. To understand all items and activities of highway and structure in BOQ, you have to take a look of a drawing of a highway cross section and a box culvert. According to sequence of execution of all activities from scratch to finish of the project. Guys, this is bill number 1 and first 6 activities of bill number 1, which are clearing and grubbing, removal of trees, which have three categories according to size of the girth, compaction of natural ground, excavate unsuitable common material, are executed on NSL. Guys, this is a cross section of a road, and this dotted line shows NSL. NSL stands for natural surface level. As I shown you in the BOQ, first activity is clearing and grubbing. In this activity, contractor have to remove all the bushes, stumps, roots and trees under 150 mm girth up to the specified depth from NSL. Next activity after clearing and grubbing is compaction of natural ground. Contractor have to compact the natural surface level according to the drawing and specifications. And contractor have to remove all the trees coming in the roadway, which will be paid in three different rates according to the size of girth. Clearing and grubbing and natural ground compaction is paid in square meter. Unit of measurement of removal of trees is each or numbers. Item number 106A, excavate unsuitable common material, which will be measured in cubic meter. Any kind of unsuitable material found in NSL will be cleared and disposed of out of the project by the contractor. Guys, next item is formation of embankment. Formation of embankment will be done in the layer of 150 mm over and over from the NSL up to bottom of improved subgrade, and compaction will be done according to drawing and specifications. Further, guys, formation of embankment have four different types. Number 1, 108A, formation of embankment from roadway excavation in common material. For example, guys, this is a cross section of partial cut and fill portion. Right side of this cross section falls in fill portion and left side falls in the cut portion. On the left side, NSL is raising above the FRL level. Contractor have to cut this soil from NSL to the bottom of improved subgrade and shift the material to the fill area to make embankment. This activity is called formation of embankment from roadway excavation in common material. Or if the material excavated in this activity will be unclassified rock material, then this activity will be called formation of embankment from roadway excavation in unclassified material and will be paid in different rate. Item number 108C, formation of embankment from borrow excavation in common material. Guys, if material from roadway excavation is finished, then contractor have to borrow the material from any outer source approved by the engineer. Item number 108D is formation of embankment from structural excavation in common material. Common material found from excavation of structures is also utilized in formation of embankment, and this activity is called formation of embankment from structural excavation in common material. Unit of measurement of embankment is cubic meter. Item number 110 is improved subgrade. Guys, according to this cross section, improved subgrade is laid in thickness of 300 millimeters on the top of embankment. Unit of measurement is cubic meter. To take off quantity of clearing and grubbing and compaction of natural ground, you have to take the width of NSL from catch points of the slopes on the both sides of this cross section, NSL from this point to this point, and multiply it with the length of your work done area. And to take off quantity of embankment and improve subgrade, you have to take cross-sectional area from this cross-section in AutoCAD format. This area is the area of embankment from the top of NSR to the bottom of improved subgrade. And this is the area of improved subgrade. To take quantity in cubic meter, you have to multiply these cross-sectional areas with the length of work done. Contractor have to put all rates in this column after doing proper rate analysis. And after putting rates, amounts will be displayed in amount column. And this is the total amount of all activities of earthwork. Bill number 2 is sub-base and base course. After earthwork, contractor have to prepare sub-base and base course layers. In this cross section, sub-base course is laid in the depth of 150 millimeters. This one is layer of sub-base. Unit of measurement is cubic meter. And in the same way, aggregate base. In this cross section, aggregate base course is laid in the depth of 250 millimeters. This pattern of hatch shows aggregate base course. Unit of measurement is cubic meter. Next activity after aggregate base course is in bill number 3, surface courses and pavement. Bitumen prime coat. Bitumen prime coat is sprayed on the top surface of aggregate base course before laying asphaltic base course layer. It is also called seal coat. Asphaltic base course is laid in the depth of 160 millimeters according to this cross section after spraying bitumen prime coat. This pattern of hatch shows asphaltic base course layer. Unit of measurement is cubic meter. Next activity after laying of asphaltic base course is also in bill number 3, surface courses and pavement, which is bitumen tack coat. Unit of measurement is square meter. Bitumen tack coat is sprayed on the top surface of asphaltic base course before laying of carpet surface asphaltic concrete wearing course class A, which is measured in cubic meter. In this cross section, asphaltic wearing course is laid in the depth of 50 millimeter, and this is the top surface of the road. Also called FRL, stands for finished road level, and PGL, profile grade level. Item number 206B is waterbound macadam This material is used on shoulders and service roads. Unit of measurement is cubic meter. Item number 209A is breaking of existing road pavement structure. Item number 209B is scarification of existing road pavement. If there is any existing road in the construction area of the road, the breaking of top pavement surface will be paid in the item of scarification of existing road pavement, and breaking of its pavement structure will be paid in this item 209A. Next item in bill number 2 is rigid pavement for toll plaza portion. Guys, rigid pavement is provided in toll plaza portion of the road or sometime in outer lane of the road for heavy traffic. And its first activity is lean concrete placed on sub base or base course according to the drawing. And next one is concrete class A1 on ground. Concrete class A1 is poured over lean concrete according to the drawing. Unit of measurement of both concretes is cubic meter. Item number SP201 is supply and installation of tough pavers or tiles. It is provided in service areas, toll plazas or walkways. And unit of measurement is square meter. Item number 304C in bill number 3 is triple surface treatment, and unit of measurement is square meter. TST is normally done on top of the shoulders and service roads. Bill number 4A structures box culverts. First activity of structures is structural excavation, which is started from the beginning of the project parallel with earthworks. The unit of measurement is cubic meter. Guys, this is a long section of a box culvert, and you can see this dotted line. This is NSL, stands for natural surface level. Contractor have to excavate this surface up to bottom of lean concrete. This is the bottom of lean concrete. This activity is called structural excavation and paid in cubic meter. Next activity after structural excavation is lean concrete. Lean concrete is poured after completion of bed. Next activity will be reinforcement as per ASTO. Steel bars will be fixed according to bar bending schedule before concrete pouring of base slab. Concrete class A2 underground cut-off wall and concrete class A3 on ground base slab. This hatch shows base slab on the top of lean concrete. In this drawing, thickness of base slab is 450 millimeters. Next activity will be again reinforcement of walls, and after reinforcement concrete class A3 elevated abutment walls, top slabs, wing walls and parapet walls. And for abutment walls, you have to take a look of cross section of this box culvert. Guys, these are abutment walls of this box culvert. Height of wall is 4 meter. Width of wall is 400 millimeters. This is top slab. Width of top slab and base slab is 4 meters. Thickness of top slab is 450 millimeters. Fillets are also provided on the base slab and top slabs. Unit of measurement is cubic meter. After completion of complete structure of box culvert along with wing walls and parapet walls, backfilling will be done, which is granular backfill and common backfill. This hatch shows granular backfill on the both sides of abutment walls, which is done in the width of 500 millimeters. Item number 406A. Pre-molded joint filler 25 mm thick with bitumistic joint seal. It is filled between construction joints and paid in square meters. Item number 406 DII is PVC water stops 9-inch size, paid in meters. It is also fixed in joints before pouring of concrete to control water seepage. Riprap class B, grouted riprap class A, filter layer of granular material. It is protection work provided on the slopes of embankment and on the bed of inlets and outlets of the box culverts. To protect slopes of the embankment from rain cuts. Unit of measurement is cubic meter. And this is bill number 4B, structures, retaining walls and breast walls. Again, structural excavation in common material. We have already discussed this item. And this is backfilling with rock material. Backfilling with rock material is done behind the retaining walls. Concrete class A3 on ground is used to pour the base slab of the retaining walls. Concrete class elevated is used to pour stem of the retaining walls. And this is again lean concrete. Plumb concrete is also used for construction of retaining walls and breast walls. It is also called cyclopene or rubble concrete. Concrete and stone is mixed with the ratio of 2:1. And unit of measurement is cubic meter. Again, reinforcement. Steel wire mesh for gabion and rock fill in gabion. These both items are used to make gabions in outlets of box culverts and in front of stilling chambers of chutes to protect the earth from damage of water. And this is bill number 4C, structures, underpasses. All items of this bills are as same as bill number 4A, box culverts. Guys, now we will discuss bill number 4D, structures, bridges and flyovers. And this is again structural excavation, granular and common backfill. In construction of bridges and flyovers, first most activity is boring of piles. Item number 407D1, cast in place concrete piles up to 1 meter dia in normal soil. Cast in place concrete piles up to 1 meter dia in gravel soil, boring only. And item number 407D, cast in place concrete piles 1.1 to 1.5 meter dia in normal soil boring only. Item number 407D4, cast in place concrete piles 1.1 to 1.5 meter dia in gravel strata boring only. These are two different sizes of dia of bores and two different kind of strata, normal soil and gravel soils. 4 items have different 4 rates and will be paid in running meters. Item will start reinforcement. Cages for pile will be prepared and lowered in the bore of the piles. Next activity will be concrete class A3 underground piles. Pouring of concrete class A3 will be done in the bore holes, concrete piles foundations. Precast concrete class D1. Concrete class D1 is used to cast concrete girders. This activity will start soon at the beginning of activities of bridges and flyovers and will be paid in cubic meters. Pre-stressing wire strands. Pre-stressing wire strand is used for stressing of girders and is paid in tons. Next activity is concrete class A3 elevated. This concrete is used to pour piers, transom, deck slab, diaphragms, coping, beam seat, back walls and wing walls and is paid in cubic meters. Elastomeric bearing pads. Elastomeric bearing pads are placed on transom seats before launching of girders. After that, activity of launching of girders will be done and is paid in tons. Lean concrete is done under pile caps or approach slabs and is paid in cubic meters. Concrete class A2 on ground is used to cast approach slabs and is paid in cubic meters. Reinforcement structure shapes paid in tons. Structure shapes like louvers and grills on edge barrier of bridges is paid under this item and unit of measurement is ton. Pile load test for dia 1 to 1.5 meter, 2.5 times of design load. Proof load test on working piles, 1.5 times design load, paid in each numbers. Heavy loads are placed on working piles or test piles to perform the load test of the piles. Permanent pile casing liner 12 mm thick for piles. This pile casing is provided on the piles in the river areas or waterlogged areas. Sonic integrity test SIT on all piles is done on the piles and paid in each. Routed riprap class A filter layer of granular material is provided for protection on the slopes of fill and on the abutments of bridges. Manufacture trademark expansion joints for roadway. Expansion joints are provided between the joints of deck slabs and paid in meters. GI drain pipe dia 100 mm. It is provided for drainage of water from top surface of the bridge and paid in meters. Next is bill number 4DI, structure soil investigation for bridges. Guys, all the tests about soil investigation for bridges and flyovers are done and paid in this bill. Bill number 5, drainage and erosion control works. Concrete class A1 on ground is used to make chutes and ducts. Chutes are provided on the surface of embankment, used for disposal of water from the top surface of the road. Ducts are made for service crossing, for utility lines or electric lines from the bottom of the road. RCC pipe culverts are also used for crossing of drains. Concrete class B is used for bedding and encasement of pipe culverts and paid in cubic meters. Steel wire mesh for gabion, rock fill in gabions. Routed riprap class A. It is protection work on the slopes of embankment. Dismantling of structures and obstructions. If you have any structure or obstructions in the construction area of road, you have to dismantle them, which will be paid in cubic meters. Crowded stone pitching 20 to 25 cm thick with bitumistic joints. It is done for protection of embankment slopes from rainwater. Supply and installation of PVC pipe 100-150 mm dia used in service ducts, for crossing of cables, relocation of unlined water courses, relocation of brick-lined water courses, paid in square meter. Now bill number 6, ancillary works. RCC New Jersey barrier in situ for median. New Jersey barrier is provided in center median of the road, and RCC New Jersey barrier in situ on retaining walls and road protection above 7 meter fill height as per drawings. Precast curbstone in concrete class A1 including bedding, haunching as per drawing. Curbstone are provided on the edge of the road for protection purpose. Metal guardrail is also provided on the edge of road for the protection. And these are traffic road signs category 1, 2 and 3 C, paid in each and square meters. And this is pavement marking in TP reflective paint for 20 cm width, paid in meters. Used to provide lane dividers on the road. Pavement marking in TP reflective paint for 4 meter arrows. Arrows are provided on the road surface, and these are reflectorized plastic pavement studs. Unit of measurement is each. Galvanized wire mesh fence 1500 mm high, including pre-stressed and RCC post, complete in all respect. A wire mesh fence is provided on the both sides of road to stop movement of cattle and pedestrians on the road. Delineators and angle reflectors are installed on the edge barriers and median barriers for reflection purpose, mostly on the curves of the road. And these are gantry signs type 1 and type 2. Now guys, bill number 7, general items. Activities like provision of office and residence to the employer and engineer representatives. Furnish and equip the employer and engineer representative office and residence and its maintenance on monthly basis is paid under this bill along with transport. Now guys, totals of all these 7 bills will be carried forward to the main summary of the BOQ. And this is the main summary of BOQ. These are total of all bills, and this is the grand total or BOQ cost of the project. Guys, sometimes contractor offer rebates or discounts on the BOQ cost of the project. Net amount after rebate will be called original BOQ cost of the project. Thanks for watching guys. Hope you will like this video. It was really hard working. So please subscribe my YouTube channel and must press bell icon so that you will get updated with my new videos. Thank you very much and Allah Hafiz.